Okay, so hello everyone. Welcome to my channel. So today I will be explaining my detailed end-to-end machine learning project on online payment fraud detection. So let me quickly share my screen. Okay, so first we'll be going to our command prompt. So in this command prompt, I've used the CD to go to the current directory of the folder that we have done my project in, which is online payment fraud detection. So once we go into this, I have used code space dot to open a VS Code instance on this folder. So the first thing that we'll be doing whenever we start a new project is to create a virtual environment. So I've created the virtual environment using the terminal in the command prompt. So once I've created the virtual environment, we require two things, that is requirements.txt and the setup.py. So in the requirement.txt, we'll be adding all the packages that we'll be needing. So like pandas, numpy, matplotlib, etc. So in the later stages, we can add some more packages that we want in our project to work. So when I started the project, I have until this sklearn, this scikit-learn up till the 5 part, and I have added the remaining at the later stages as and when required. So then I've created this setup.py, so which will be responsible to basically set up my project. It will be responsible to find the packages from the pip library as well. In the later stages, I can also host it in the pip library as well as this total project as a module as well. So before looking at the data, so there are some basic things that are required for any project. So which I've done. So I've created a basic project structure. So I've created in source folder SRC, and in this SRC folder, I've created two new subfolders: containers, components, and pipeline. So in this SRC folder, I've created an init pipeline, init.py file, because every empty folder, whenever we go inside a folder, we have to create an init py file to initialize the folder. So in this root SRC folder, so we have three things: exceptions, logger, and utils, which the names are pretty self-explanatory. So this exception will .py. I've created some. I have created a custom class called custom exception, which will be helpful for me to raise any errors so that I can easily see it. So the error format will be error occurred in the Python script name, right, in the line number, and what is the error detail. So this is the basic template for it. We can get it. After that, I've created a logger.py, so which will be helpful for me to logging. So what are the steps completed in the project whenever I run it. So this is the logging. So I imported logging OS and date time. So the format for the logging will be time, line number, right, level name, and what is the message. So let me show you a log. So this is my first log, right? That the logging has started. So whenever we complete a step, the logging will be here from the time and the route and the info and the message will be displayed. So this is the logger.py. So this is the basic setup done. So I'll be breaking this into three parts. That is breaking the total project into three part: data ingestion, data transformation, and model trainer. So so first thing is we'll look into the data first. So I've created one more folder, notebook. So in this notebook folder in the online payment fraud detection. So once I open this notebook, I have kept the data, that is the CSV file which I've downloaded from Kaggle, that is online fraud.csv. Yes. So one more interesting thing here, right? So whenever I was initiating GitHub, so the GitHub as has the limit of 100 MB of any file, and this file is around 700 MB. So I have added a GitHub LFS extension, and during this GitHub LFS extension, so I've created a .git attributes where I'll be tracking this online fraud.csv, because the GitHub general GitHub doesn't support more than 100 MB, so we have to use the GitHub LFS, that is last file storage. Also, I've created a git ignore file, which comes as a template from GitHub only. So here I'll be adding all the environment variables and all the details that I don't want to show it in my GitHub. So here, for example, I have used the VMB folder, which is my virtual environment. So because we don't need it, so I have kept it here. So let us look at the data now. So I've done some basic EDA. This is just IPYNB file. That is the Jupyter notebook file inside the notebook. So these are all the features available. Step tells us about the time. Type is the type of the transaction. Amount is the total amount of transaction. We have the name, old balance in the original account. Old balance is the new balance is the original account. Name of the destination account, old balance, new balance, and whether this is fraud or not. So let us import the basic packages, basic packages or libraries that are necessary for some ET. So when we read the data, so this is how the data looks like. So here we find that we have the old balance, the new balance, and the amount as well. So I was just checking whether the new balance, old balance minus new balance, this value which is equal to the name amount or not. So I've created a new column amount one, right? So I'll be checking the value of amount and amount one, whether they are same or not. So the value is same. Just the sign is changed because I've just actually subtracted the new balance from the old balance because the money is debited. So it will be a negative. So it is pretty self-explanatory. So we see that the values are same. So either the old balance or the new balance is redundant. So we'll be removing it in the later stages. Right now, we are just drawing some conclusions so that we can use it in our data ingestion transformation and the model trainer. So these are all the columns. So unnamed, the step type and all of this. So this unnamed is just the serial number. So we'll be not needing that. So we'll be dropping it. So this is how the data looks like. So I found a random five columns, random wide entries to see how the data looks like. So when we look at the info, we see that there are some float columns, data types. There are some object data types, and there are some integers as well. So when we describe it, the values are very different. So these are the statistical analysis of them. So after that, if you see the categorical variables, integer variables, and the float variables, we see that there are three categorical variables and there are six float variables. And I have created the numerical variables is equal to integer variable plus float variables. Simple. So these are all the numerical columns. So first we have found the counter for the payment type. So there are basically five types of payment type that we can see here. So payment transfer, cash out, debit, and cash in. So from this we can see cash out and payment are the majority, and debit is the least. Similarly, we have done the bar plot for analyzing the type and amount of columns simultaneously. So, which type of transaction we get the largest amount? So we can see that the transfer type of transactions have the larger amount involved with them. So this is the inference. Both the graph clearly show that mostly the cash out type and transfer are maximum count as well as in the amount. So then we see the distribution among the predicted prediction values. So this is the output. This is the y value. So when we check the value counts, we see that this is a highly imbalanced data set. So we have just only 1854 fraud detection. So this will be usable. This will be used when we implement the machine learning models. Which models will be more suitable for this? So now we saw the step column was the measure of time. So in order to get a clearer graph, we see the KD plot. And also after that, we saw the heat map for the correlation. So here we come up with something obvious, that is the new balance and the old balance in the original account are pretty correlated. And similarly, the old balance and new balance are also pretty correlated. This correlation is for the numerical columns. Simple. So now we look at the shape of the data. So there are around 17 lakh entries, and there are 11 columns each. And now we see that the fraud transactions, there are only cash out and transfer transactions. Earlier we saw that there are actually five types of transactions. But the fraud transactions are actually from cash out and transfers only. So then I saw the non-fraud transactions are well distributed among all the types. So then I saw the step. So actually, the step values were a little bit different. So how it is the unit of time, I was a little bit confused. So I was just checking for unique values. So there are some 162 unique values. Okay, so after that, so I've done a KD plot for the amount. So we see this amount and we can infer from here as well. And then I checked for null values. So there are no null values. That is a great thing. After that, so we saw that the old balance destination. So when we saw the old balance destination, so there are zero in all the some values, and also when we look at the data head, so this is just normal. So the name original, and so now let us go to the data ingestion part. So we'll see how we can ingest the data in the model, how we can transform it, and how to train the models as well. So let me go into the data ingestion. Okay, so in the data ingestion, so in every Python file, okay, so in every Python file, I'll be importing this exception and the logger file so that I can raise any custom exceptions if there are any errors, and also I can log the values. Also, I have imported the data transformation and the model trainers classes here as well, which I'll be discussing later. So I've imported also data classes, right? So that all the classes in all these three can be imported in one data class as well. So first, what I've done is to create the file path for the train file, train CSV, test CSV, and the data.csv. So here we'll be looking into how to ingest our data. We have to make our data ready for ingestion. So I've created an initial by self.ingestion.config, data ingestion config. So I've created a logging that is enter data ingestion component. So first we'll be reading the data. Df is equal to pt.read underscore csv, and we have the location. So this is the notebook data online fraud, right? So under the notebook, this is the online fraud where it is ready. After that, we will be making the directory where we'll be adding the train test and data.csv. So we'll be first we'll just copy the data first so that it is useful for us later if I delete this online fraud.csv from the notebook folder as well. So this is the we have created the raw file path here, that is data.csv under the artifacts. Similarly, I've created the train and test as well. So I've used the train test split from the sklearn with the ratio of test size as 0.2 and the random state 42, so that our values don't change if I run it again. So ingestion is complete. So this is how we can make our ingestion. And also every time we try to keep all our important functions, important codes inside the try catch block. So try exception so that we can raise a custom exception if we want. We'll be coming to the last part of if underscore underscore name equal to underscore underscore main in the later stages. So here the data ingestion is complete. That is, we have made our data into train and test. After that, we'll be doing the transformation. Here also, as explained, I'll be adding the exception and logging, importing them, and then I'll be creating two file paths. So first one will be to the feature to the pre-processor and the feature processor. So from the EDA, right? It is clear that this unnamed column is not required. And also from the old balance original and the new balance original, I'll be removing the old balance original. And similarly, the old balance destination and new balance destination, I'll be removing the new balance destination. So I've created a function named it dropped column from the function. So return x dot drop columns, drop columns. Simple. Similarly, I'll be adding some functions as well. I'll be adding some features as well. So I've added two features. So this name original, I've seen it earlier that there are some accounts which has a lot of transactions. There are like 4, 5, 7 transactions. So what I've done is I have made the name original frequency as a feature, which I'll be mapping the frequency encoding of the original file. That is, I'll be adding here how many times this account name is used in the transaction. Similarly, the destination account for the destination account as well. So now I'll be creating a feature pipeline so that it is optimized. So I will creating a pipeline. So first I'll be adding the features, that is the name original frequency and name destination frequency, and then I'll be dropping this unnamed new balance and the new balance destination. So this is my function for that. After that, we have the numerical columns and the categorical columns. So I'll have to scale them and encode them properly. So for the numerical columns, so I've created another pipeline. So first I'll be imputing using the strategy mean. Of course, there are no none values. So, but if there are any null values in the upcoming future, also we can handle it here. Similarly, after that, we have scaled using the standard scalar. Similarly, for the categorical pipeline, I will be simply imputing the most frequent values on the column on the objects. Then I am using the one hot encoder to encode our categorical variables, and then we have used the scalar, right? That is the standard scalar. So then I've used the logging pipeline are complete, right? And then I have used the pre-processor. So basically, I have used a column transformer here. So that is, the numerical pipeline will be added to the numerical columns, and the categorical pipelines will be implemented in the categorical columns. Simple. And then I've just written the feature pipeline and pre-processor. So this feature pipeline, so this is the feature pipeline where I'm adding and removing the features, and we have the pre-processor. So I will be returning them here, and I'll be calling them in this function. So where I'll be saving them. Yes. So I've written the feature pipeline and the pre-processor here. So then we have one more function here, which is the important one, that is initiate data transformation. So I'm reading the train file and the test DF. So reading is complete. So the feature pipeline object dot preprocessor object, I'm getting them from here, and the target column name is fraud. So first I'll be removing the target column name from both the test and train files, and after that I'll be applying the feature pipeline and the pre-processor. So first I'm using the feature pipeline here and using the fit transform, and once I've done the fit transform in the train dataset, I'll be using the transform in the dataset. Similarly, I've used the pre-processor object that we've discussed earlier. So here we have done that, and after that I have saved the object. So actually this save object and all the basic functions that I'll be using, I'll be keeping it in the utils.py so that it is easier for me to find out in the later stages. So this is the utils.py. So this is the save object function that I've created. So this is nothing but any object that I'll be needing later in my feature pipeline or the train pipeline. I will be creating an object for that using the dill. So I've created the file path, and in this file path, I will be just dumping them. So as you can see, when we dump it, so here we have the feature processor and the pre-processor, this PKL files, and the later definitions will be going forward. I'll be telling you about that when we go forward. So here data transformation is complete. So in this data transformation, what we have done is actually we have added some features. we have dropped some features, and also uh, we have uh, we have scaled, imputed, and encoded the features as well. Okay, so the next part is to implement the model trainer. So here we have the model trainer. So as we discussed, this was a pretty imbalanced data set. So here also we will need to save the model as well. So the model file, I've created the file path under this class model trainer config, and then we've initiated the model trainer. So in the model trainer, we'll be using the logistic regression, LGBM classifier, that is light GBM, and then we have the XCP classifier, cat boost classifier, and the random forest. We are using only these classification models because these are more suitable for imbalanced data sets. So in the class bits, as you can see, we have just changed some of the uh, some of the parameters here, which we can hyperparameter theory in the later stages as well. So I've created a new variable that is model report, where I'll be evaluating the models and printing the reports for that as well. And also I've created one more so so, so this this model report is also again in the utils.py. So let me go to the utils.py. So this is the evaluate model. So whenever we give the X train, Y train, X test, Y test, and the models, so it will be fitting all the models. It will be predicting. So we are checking the true positive, true negative, false negative, true positives, precision recall F1, and the Matthew coefficient scores. So I'm creating a database from here. And also this database is pretty necessary. So I'll be saving it to the CSV. So I've created another definition of a function, save report to CSV, where I'll be giving the report and the output direct. So this is my evaluation report. Let me show you evaluation report. Yes, just let me come to here first in the model trainer. So I am finding the model report. In the model report, I'm printing the model report here, and also I'm saving in the model report in the outputs folder, right, in the evaluation reports. So uh, after that, the model sorted. I'll sort the model by MCC, that is the Matthew coefficient, and I'll be finding the best model and what is the best model score and name. So let me show you a model. Let let me show you the database. So this is actually a CSV file, right? Uh, which is pretty difficult to read if it is like this. So I've created another small Jupyter file tt.ipynb. The name is pretty random, just for me to check. So here, so these are the values. So when I use the logistic regression, light GBM, XGB, cat push, and random classifiers, so these are all the values of true positive, true negative, false positive, and false negatives. And definitely looking at the MCC, obviously the random forest classifier has worked the best, right? So the random forest classifier, if we sort it by MCC, we see that the random forest classifier has the largest MCC coefficient, that is the Matthews coefficient. So we'll be using this. So if I come back to our model trainer, so when we see the best model name, it will be obviously random forest classifier, and the best model will be models, and from the it will be taking the best model name, and the logging also will put it here. So let me go to the logs. So these are many logs that I've created when I've run this data many times. So these are all the logs. So if you come to any of log, so here logistic regression was the value. So here we have the random forest classifier has the highest score. In this logging also we can find it now, which makes the entire process a little bit easier. So this is the model trainer. Also, I've saved the model as well using the same functions that I used to save the feature processor and the preprocessor as well. So I have saved the model as well. As you can see, here we have the model.pkl, which is the random forest classifier. Simple. So our all the models are done. So now the next part is the predict pipeline. So we'll be creating an entire pipeline. So where we'll be adding the input values and all the values of and our prediction will be pipeline. Simple as that. So this is the class predict pipeline. So for that, I'll be needing to load the objects that I've created, these PKL files. So I've created one more folder, one more definition, one more function in the utils.py to load the folders, as well, load the object as well. So here we have the function. So deal.load file object. So this is the predict pipeline. So first this is the model path. So I won't be requiring the feature procedure part because I will not be giving the feature procedure because I'm creating an end-to-end website for it. So I'll be giving it only the values that are needed. So I'll be pre-processing it, but the feature procedure inside the feature procedure there were only dropped some columns and there are some there are some frequencies, right, which I'll be adding manually because we cannot add more than one data at a time in a website as of now. So loading the model and also I'm loading the pre-processor. So first I'll scale the data. Data scaled is equal to pre-processor to transform the features, and then I'll be finding the predictions. Simple. So these are all the columns. These are all the features. So then I have created a new class known as custom data so that it is easier to store the data inside this class. So we have the step self.step type self.type etc. and all the values. And actually I am converting it to the data frame. So this get data as frame. We have created a new function here so that I can convert it into a data frame which I can put inside here. So here you can see. Yes. Okay, so get data is data frame. So this is the custom input data, right? So I'll be converting it to the data frame. So once the predict pipeline is complete, so now it's time to host it. So I have created a streamlit app.py. So these are the basic structure. So I'll be giving the values, the type, right? What type of payment is it? Payment, transfer, cash out, debit, etc. I have given some help values so that it is easier for any user to put some values. I'll be visually changing some of the values, but the core concepts will be same. So similarly, in the later stages actually. Similarly, this step, right? The value of steps I've given from 1 to 1,000. Similarly, the amount, name frequency, that is how many times the original account has have transacted. Similarly, what was the old balance? That is previously, that is before giving the final amount, before transaction. Similarly, the name destination frequency, old balance, and have created and all the values that are fetched from the user are coming to the custom data. I am converting into a data frame. So once I've converted it into a data frame, I will implement the predict pipeline so that I can predict the value. So if prediction equal to 0, we'll say it is a non-fraudulent transaction. And if prediction is equal to 1, we'll say it is a fraudulent transaction. So let me quickly take you to the website as well. So this is the website which I've hosted using Streamlit, which I've shown you the code of. In the meantime, let me open the GitHub as well. Okay, so this is the basic online fraud detection. So I was just taking the names and email ID. I was just checking something. In the later stage, it may be available, it may not be as well. So if my name is Devan, if I'll add enter, So hello there, everyone. Welcome to the app. So I was just using some visual changes. So these are not necessary as of now. So if I select the transaction type, so here in help also, we can see what type of data is required. So let me say this is a cash out type of transaction. So let me give a value of step. Let us say 15. We'll enter an amount, a random amount, and we'll see how many times the original account has transacted in this step, that is this specific time. So let me say 3 times. So what was my old balance, that is previous to this amount transaction? So let me say 90,000. Okay. So next we'll be adding the number of times the destination frequency. Let us say I have given it to a vendor. So vendor may have a lot of transactions in his name. So the destination, let us say, has transacted more than 90 times. So what was the old balance, the previous balance, let us say, before the transaction was completed on the destination. So let us say it was 20,000. Okay. So we predict. So these are the inputs that I have given, which I have shown it here, and it is a non-fraudulent transaction. So it is pretty normal to give all the values and get a non-fraudulent transaction, because as we have seen from the EDA, the amount of fraud transactions are very less. So from 17 lakh values, there are only 1800 values. That is around 1% of we can say 1%, right? Okay, so 1800 divided by 17 lakhs. So this is very less, right? So yes, so this is 1% only. So only 1% values, we can say they are fraudulent. So later I'll be adding the sidebar, and these are just visual changes that I'll be doing. The basic is just the same. So if I go to the GitHub, so this is my online payment fraud detection. I've done some more projects on some regression problems as well, some more classification problems as well. Okay, so this is the file. This is the GitHub. So you can fork it here if you want. And if you have any questions, please share it to me using any of the channels. Okay, thank you. Bye, everyone.